Hello everyone. I want to make a quick video explaining how to use the IMBootloader with STM32N6 series microcontrollers. I recently added support for it in this project, so to use it properly, there are a few things you need to understand. First, you need the first stage bootloader. This is the part that runs entirely from RAM. To verify that, you can open the linker script and you will see that the code is indeed executed from RAM. These are RAM addresses. The variant with a signature is the same bootloader, but it also includes a signature required by the IMFlasher application, so it can be programmed correctly to the target. Next, you have the second stage bootloader. This one is used after the first stage bootloader. The idea is simple. The first stage bootloader runs from RAM, and then the second stage bootloader frees up the RAM region it occupied. This large memory region, extending through the AXISRAM2 area, can be treated as one large block of contiguous RAM. That is more than 4 megabytes of RAM, which is very impressive for a microcontroller. To flash your firmware into this memory area, you need to use the second stage bootloader. The first stage bootloader performs the initial setup, then jumps to the second stage bootloader stored in external flash in memory mapped mode. The second stage requires a small amount of RAM, so I reserved cachexe for it. For some reason, I could not place it in the vencram, but this is just an example. Once both stages are running correctly, you can copy your application into this large RAM area and use the remaining space for heap, stack, static data, or anything else your application needs. To be able to do this, you need STM32Cube IDE. When I worked on this, the standard OpenOCD did not yet support this microcontroller. After setting up the IDE and ST-Link, you need to flash the first stage bootloader to RAM. Make sure the jumpers on the Nucleo board are set to debug mode. Here I am using the IMLedBlink example application. Let me press debug. The code is now loading into RAM. To enter bootloader mode on the Nucleo board, I press the blue user button, then start the program. While holding the button, I click play. The LED on the Nucleo board should light blue. If I stop execution here, you can see I am inside the communication loop. This loop waits for IMFlasher to connect. Here is the IMFlasher application. Be sure to connect both USB cables, one for debugging and one for USB communication with the microcontroller. When I press connect, the tool detects the bootloader running from RAM. You can see the git hash, branch, and tag. After a moment, the board ID appears. Now I will flash the second stage bootloader. Make sure to flash the signed variant so both the bootloader and IMFlasher can verify it. While flashing, you will see the LED blinking. After the flashing completes, IMFlasher reconnects automatically to the second stage bootloader, which is now running from external flash in memory mapped mode. That is how you can confirm it is the second stage bootloader. Let me pause execution to show that the second stage bootloader is indeed running from external flash. Now I will continue and load the application. You can download IMLedBlink from the cloud through IMFlasher, but here I will open the binary manually from my computer. The file is signed and pre-built. During flashing, the LED blinks rapidly because we are using the same LED indicator. After flashing finishes, the LED blinks slower, which indicates the IMLedBlink application is running. The new git hash and tag confirm that the new application is active. If I pause execution again, you can see I am inside the IMLedBlink application and can step through the code. This shows the complete workflow. IMFlasher also supports console options, which means you can automate the process with scripts. After flashing the second stage bootloader once, you do not need to flash it again. You only need to flash your application and start debugging. To summarize, you need to flash the first stage bootloader each time because it runs from RAM. With a bit of scripting and IMFlasher, the workflow can be fully automated. I have built similar systems for other microcontrollers, and I expect it would not be difficult to adapt it here as well. If you have any questions, feel free to ask in the comments. If it makes sense, I can create more videos on related topics. Thank you for watching, and please like and share so others can learn how to use these tools.